Hey folks, continuing with mechanisms, I want to talk about two mechanisms that change rotational motion into linear motion. It still has the worm wheel stuff in it. We're going to talk about a lead screw mechanism. Now, a lead screw mechanism is something used to change rotational motion to linear motion. The lead screw itself is kind of like a worm. It's got threading all the way around, a single tooth that advances once per rotation. So as you turn the crank here in this picture, this whole part of it here, the worm, well, the lead screw part of it turns around once, and that will that'll make this guy go one tooth distance in whichever direction you turned it. The lead screw segments can all be put together, so you can make a longer lead screw, or you can always, like, there are items that use lead screw mechanisms that don't have to be slid onto an axle. You just have a giant bolt basically that spins around. And the thing that moves usually in a scenario like this is the nut. This is a lead screw nut by Vex right here. You can see it from the side here. It kind of looks like an I-beam segment. What it is it's got a bit of that threading on the inside of it, and so as this lead screw turns, this part is going to be moving along back and forth. And the way it's set up, it's attached to a slide truck, which is attached to a linear slide track. And so what that does is it keeps everything going in a line. This guy doesn't spin around at all. If it's not attached, it'll spin around, or it'll be hard to tell what's happening. But this way, as I turn this crank, this piece moves straight along this line in a linear fashion. So that's exciting. You'll see this in real life in linear actuators. This is a really crummy picture. When it's up on the screen, that's got a really crummy projector. It doesn't look as crummy as it does here. It's kind of crummy looking. What happens as the motor here turns this lead screw is that this plate that's attached to the nut will slide back and forth along here. And so an actuator is just something that that makes some part of your machine move. You know, it could open and close a valve. It could bring a print head into range to print on something, move it around back and forth. That's what an actuator does. And so linear actuator is something that its end motion is linear, back and forth. Here's some machine slides. If I turn these guys, it'll move the slides along in a linear fashion. And what that does is, in this case, I don't know what kind of machine this goes with. It usually is like a saw or some heavy machinery, but you can move items into and away from the saw blades. Vices. As I rotate this crank, the two surfaces here come closer or farther apart, so you can pinch something you're working on. If you turn it and tighten it in one direction, it'll pinch it, and then you can loosen it and take your item out after you've drilled holes in it or sawn off part of it, whatever it is you're doing, whatever you need it held still for. Here's a press. There are 4 lead screws here, so each one of these lead screws will spin, and the 4 places that it's holding in place, those are nuts, and the whole thing will come down or go up again. And here's a jack. Lead screw slides up and down, and in this case, this is the part that's, I think, moving up and down. Now, another mechanism that'll translate rotational motion into linear motion is called a rack and pinion. The pinion is just a regular spur gear. It might be kind of small, like this one looks really small. The rack is a flat gear. It's like got teeth all in a row. It looks like a serrated saw blade that's been extruded out. The rack is usually the part of it that's attached to a slide truck, but you can have the pinion gear attached to a slide truck too. If I've got, right here, you'll notice these teeth, they're not perfectly vertical, they're at sort of an angle. They're helical or helixical, I can't remember how it's spelled or how it's pronounced, but it's kind of like a helix. It kind of spirals around on the side of it there. And that'll change the torque, that'll change how these surfaces interact with each other, and so sometimes that gives you more power out of this sort of a setup. But in this case, if I were to turn this pinion gear, the rack's going to slide back and forth. And it looks like this part is held still and the rack piece is what's going back and forth through that little track there. And that's a slide track for it. That's going to hold this thing's going to hold still. It's going to hold this in a linear motion rather than letting it go spin around the gear. So here's some in real life. Here's a linear actuator, and in this case, the motor here is spinning a gear, and there's a little rack in here, and as this motor turns, the entire mechanism right here slides along this rack. So that's one where the motor part, the spinning part, the pinion, is housed on the slide truck, and it slides back and forth. You might see this in a steering mechanism. Here's an example where this is the shaft coming down from the steering wheel. As you turn the steering wheel, your pinion gear you're turning. And as the pinion gear turns, the rack is what's sliding back and forth. Essentially this tube that it's inside of is a track. And what's going to end up happening is it's going to push the wheels one way or another as it goes left or right. Here's a picture from a roller coaster. When I was looking things up that have rack and pinion gears in them, I found this roller coaster referenced. I'm not sure exactly how this figures into the actual motion of the roller coaster, but I was like, hey, kids like roller coasters, right? So that's cool. I would love to look that back up and find out where I got that image from. Stair lifts. When you're older or disabled, you can't get up and down the stairs as well as you used to. This chair here has the pinion inside of it, and the rack goes all the way along, so it'll help you get up and down the stairs. Here's someone servicing one. And you can also see modified rack and pinion gears mechanisms when you look at like an ice cream scoop. If you notice these ones, the rack itself is not a line, it's kind of an arc, and as you push this guy, there's the place your thumb pushes, so you push it in, it'll rotate that scoop. This one has a rack that's along here in an arc again. As I push that around, it's going to rotate this pinion, which is going to rotate the part of the scoop. I think that's it. That is, those are the two kinds of mechanisms I have right now that turn rotational motion into linear motion. And I'm going to put a quiz up, and it'll go with this lecture, and I hope you all have a wonderful rest of your day. I'll talk to you soon. Bye-bye.